So as I was saying, so as price prediction is a regression problem. So because in that case, you are predicting. So if someone comes, you've trained your data with like 100 houses on. Hello, please background noise. Who is that? So you are training your data with, let's say, 1,000 houses in Lagos. With that 1,000 houses in Lagos, you can make predictions, right? With a fresh data. So I can go with that 1,000 houses, let's say let's say on Island, maybe in VI. I can go with that same model that I've built, that my machine have learned from, and take it to Lekki and make it, I use to make predictions, and I will get accurate predictions. Okay. And I will get accurate predictions, right? So this is a regression problem. So you'll be facing a lot of that when you start learning, or what I say learning, when you start working as a data scientist or a machine learning engineer, right? So these are the two major problems, right, faced by the data scientists, and it's the most vast. Other one, how many companies in Nigeria, right, are doing robotics? So, but you need it if you want to travel out.
Hello,
you want to expand your knowledge, right?
Hello?
So you need. Hello, Michael. Hello.
Hello?
Yes.
Hello?
I can hear you. Proceed. Can you hear me, Joe?
Yes, I can hear you, boss, but it's not that clear. It's not loud. Yes.
How about now?
Okay. Well, it's better now, but I think it's the microphone. Like the microphone volume is
Hello?
not.
From my end, Abby.
Hello?
I can hear you, Michael. Can you hear me? But you can hear me now, Joe, Abby?
Yes, I can hear you now. I can hear you.
Okay, it's clear now. Okay, so as I was saying, these are the two major issues you are going to be facing most of the time with machine learning, right? Let me switch over. Let me switch over again to this. So I was saying, for all those machine learning problems, what you are going to be using, the library of Python that you are going to be using is scikit-learn. So it's a very important library, right? Then for visualization, of course, remember in Power BI, you visualize your data as well. After, when you are done with your cleaning and everything, you visualize your data and you take it to Power BI desktop, and then you start picking visuals and you are building visuals. So the same thing, everything you are going to do with Power BI, although you know it now depends on how vast you are, but everything you can do with Power BI or Power BI, Power Query to clean data, and Power BI to make visuals. You can also do it with Python, but it's just better and nicer when you're using a proper BI tool like Power BI, Tableau, Looker, and all. So, but Python also has its own visualization tool. Which one of them is Matplotlib? So you can see it's a 2D plotting library which produces population qualities figures in variety of hard copy formats. A set of functionalities similar to those of MATLAB. So we are used to MATLAB. Which course you study, Joe? Eh?
Huh?
Which course did you study, Joe? Joe? He has not left now. Okay, maybe.
Sorry, come again, sir.
Which course did you study? Your first degree?
Me. I studied animal science, Neil.
Okay. I thought you studied engineering when you were saying MATLAB that time. You were saying yes.
No, I didn't study any form of engineering, just a bit of statistics, tiny statistics, because I did some bit of genetics stuff.
Yeah.
Yeah.
So, so MATLAB is Matplotlib is similar to MATLAB, right? You can use the plot line plots, scatter plots. I will share this document with you. Bar chart, histogram, pie chart, etc. Relatively low level, some effort needed to create advanced visualization, but no issues. There's another one called Seaborn, also a Python library that is based on Matplotlib, but it's better, high-level interface for drawing attractive statistical graphs. It's similar in style to popular ggplot2 library in R. So ggplot is a popular library in R for visualization. So uh, so ggplot. So Seaborn is an advanced matplotlib lab, advanced data visualization library in Python. So Jupyter Notebook. So you can see to import these libraries, these are the commands: import NumPy, import SciPy, import Pandas, import Matplotlib, import Seaborn. But most of what we are going to be importing now is NumPy, Pandas, Matplotlib, and what? And Seaborn, right? So, but before we say you want to import, so let me go back to my Python shell. Hope you can see my screen, guys. So before you can import them, you can only import them when you have them, right? So you have to first of all install them. Remember when we wanted to install Python, I told us we use PIP. PIP is like a framework that you use to install libraries, modules, or anything you need. So PIP. So in this case now you say PIP install what? NumPy. Import PIP install NumPy. So we are going to install NumPy first. PIP install. How do you know that? Do this. And immediately I say run. You can see it's running now. And after that, when it is installed, they tell you now you have installed NumPy. So it's running. Whilst it's running, let's go back to what we have so that so we have all this that we have to import. Then these are ways you can. So remember in Python, in Power BI, I kept saying Python. In Power BI, what do you when you want to import something from a CSV file or Excel file? What do? You go to what? Get data, Abby.
Yes.
So you go to get data and then you pick Excel. Yeah, you go to get data and you pick Excel or CSV, any pattern that works, right? So the same thing is what you have in Python. So in Python, what you use to import data is this statement or this CSV, but I don't want to bore us with this yet. So first, let us install all the libraries that we need, right? So then I want to show us something that will be useful for us as well. Do I have it? So Also, I think it has closed. Okay, wait. I'm check. Yeah, it's here. So, can you see my screen? So I'll be sharing you this with you as well. This is what we call Python. You can see what is there. Python for data science cheat sheet. Cheat sheet. So the basic libraries that you need to perform anything you want to do in Python, right, is what we have here. So you can see the first library here is what? NumPy. NumPy, you can see there is it's few word about it. How can you import it? Import NumPy. And what you see here, remember in SQL, you have what we call aliases. We can say select star from a student table. You can nickname student table as maybe ST or STD. So the same way you can nickname each libraries in Python in machine learning as anything. The reason why we are naming it, you notice that you always see NP. The reason is because NP is common. NP is something you can master. So it's not that it has any function there. So it's just to save us the stress of always coming back and say NumPy, call that library, NumPy every time. So anytime I'm pressing NP, my algorithm already knows that, okay, I'm calling NumPy, right? And these are some of the things you can see. These are examples how you can create arrays. np.array 1 2 3 np.array. So these are you can create array, and then how you can create zeros. Maybe you need matrices of zeros, matrices of ones, a range too. So this a range now, you can see it gives you, so I'm going to share it with you. It's going to help you a lot, right, as you practice. So APA A range, maybe you want to create. So if I want to generate 10 numbers now, numbers 1 to 10, all I need to do is just call np.arange. Let me check it. Okay, so you can see now collecting NumPy. I'm back to my console. Can you see this? This my part. Huh?
Yes.
Okay, so you can see now I said pip install NumPy, and it was downloading. Everything was 14.7 MB. It has installed the package NumPy, successfully installed NumPy. You may need to restart kernel, but that doesn't need. So I've installed NumPy now. So when I want to call NumPy, I will now say import NumPy as what? NP. So I'm using that alias NP. So I can do a lot of stuff now. Like for example, that array that we just said now, I can say A equals to NP dot and I'll open a bracket, maybe I'll put a 3-dimensional array. I can call A. You can see. So A is an array of 1, 2, 3. So for example, I have B already also. B is np.array. Remember array in math? This is the same array that we're talking about here. I can now say C equals to A plus B. Let's say print C. You can see what has this done? It has added 2 arrays. So this is what we call addition of what? Arrays. Remember I told us it's always very good to add comment to your code when you watch the video. It makes your code neat. Addition of arrays. I will have said, okay, maybe after this session. Yeah. Maybe after this session, I will take us to, or you can just, I will send the sites as well, so that you can just practice NumPy basics. That would be like our assignment. I want us to. So this an array, it has added these two arrays, 1 plus 1, 2 plus 2, 3 plus 3. All right. So, for example, I might want to generate number. So let's say I want to generate numbers 1 to 10. All I need to do, I'll just say print NP. Remember, NP is the short form of what? For NumPy. NumPy is a library for mathematical functions, right? NP dot what? Dot A range. So A range is the name to generate range of numbers. So A range takes 3 arguments. It takes the start. A range takes the start, the end, and the what steps. You can also check. I think I'm coming. Let me run to check. So you can say help dot numpy. I think something of such. So you can see, you can also get help. Maybe you want to know some stuff about NumPy, right? To give you, so you can see these are things you can do with NumPy. Random numbers, you can do linear algebra, you can do a lot of stuff. It's a big library, you can see a lot. If you scroll down, just want to show us. So let me scroll down. It's a big library. This explains, you can see, you can generate, you can see, aha, thank God. You can see np.arange. This is an example now. So I'm using a range 24. So what I'm saying, what that means is generate what? 24 numbers, then reshape them to be of the shape 2 rows. So it makes it 3-dimensional. 2 rows. So length, breadth, height, something like that. Columns and z height now. So length, breadth, and height. So you can do some reshaping and some. So these are NP libraries. So you can try. We can try this out. You can see NP apply over axis. You can see NP.arange. Arange takes what? The start, the stop, and the step, which I just told you now. Start, stop, step. Arange. So this is still explaining arange. There is argmax. So there is index array. You look at how you use arange as well. Reshape to 2 rows, 3 columns. 2 rows, 3 columns. After rearranging it, add 10. That's what this is doing. np.arange 6, the start. So give me 6 numbers, right? Reshape them to have 2 rows. You can see this is 2 rows, 3 columns, right? Argmax. Argmax is a function that that multiplies diagonals now. Yeah. 15 minus 10. Subtract the diagonal. So these are a lot of things you can do with. So just in case you are lost, because I know you might be having, how do I know all these ones now like this? So you don't need to really cram them. You can always come and check them. Okay, what can NumPy do? These are things that NumPy can do. You can use it to sort. You can use it to return a range of numbers. You can see a lot of them. So you can check the library. All you need to type to check the library is just to say help into brackets NumPy, and it will bring you a lot that you can do, right? So, for example, with this query now, if I want to generate 10, I'll just say print np.arange. The start, I want to print 1 to 10, but in SQL, as well, in Python, you cannot print 1 to 10. If you say 1 to 10, it will print 1 to 9. So you have to add 1 to it so that it will print 10 with it. So when I run this now, You can see I have 1, 2, 3, 4, 5, 6, 7, 8, 10 printed. So I can also say, okay, A is np dot zeros, right? Dot reshape. So I can state, okay, 2 by 3. So that what I'm saying is that print zeros. Let everything be zeros, but ensure they have this 2 by 3 means to tell you column, right? So please give it 2 rows, 3 column. If I print A now, I can print 3. Position. Okay, so 0, 0. You can see I'm saying 2 rows, but now it should be okay. Wait, let me put it inside. So you can see now that it's running. So I said, give me all zeros with what? 2 rows, 3 columns. You can see. Let me separate these 2 answers so that I can say print -n. What do I say? If you have watched the video, I know most of us have not even watched it. If you have watched the video, what's the meaning of this slash n?
To create space, to give space.
No.
No, sorry, next page. To
Next
give a
line.
next page. Next line.
So that you can see now that there is now space between the first thing we did and the second one. What I just did here is just to add comments. This one will not run together with. I can also say P. Instead of zeros, I can say ones. Give me a matrix of a 2 by 3 matrix containing all ones. Let me separate them as well by printing /n. I've done that, and then to give space. I'll delete this one, it's too long. So a lot. Now, if you check through the library I just told you, you see a lot of what you can do with NumPy, right? So you can also sum np dot sum, right? np dot sum 200, or let's sum these 2 matrices together. A comma B. Sorry. Let's run this again. That's A. Okay, sorry. Okay. A is this, B is this. Let me run this again. A is this. Okay, sum A. Object axis. Okay, I will just sum A. All of A. So addition of all of A. Let's where is all these zeros and ones? B is np dot ones print B. Let's sum B. So let's print this first. Yeah. So let's sum all of B. I can sum all of B as well. So all of this should give us 6. 1 plus 1 plus 1 plus 1 plus 1 plus 1. So I can also say A plus B. A, B. And that gives us just the addition of these two matrices. So a lot. So I just want us to get. So let's import the other libraries before we I now give room for questions before we now start real work. So let me install pip. We've done NumPy. So the next one is pandas. This one might take a bit of time. What is it? What's that? What is sounding? Okay, someone is trying to. So if you check through, okay, let me go back to our, as this one will take a time. So you can see a lot, right? np.save, np.saves, np.load, np.empty. So you need empty rows. So this will generate an empty array of 3 rows by 2 rows. np.random.random. So what this will do is it will generate random figures, random numbers. Let me open a new kernel. Now, because I've installed Python before, so I don't need to install it again, right? Sorry, NumPy. So I can say print np dot what did I say there? Okay, np dot random. So I can specify maybe I need a 2 by 3 random numbers. So name np. Okay, sorry. So I did not import np, right? Because this is a new shell. Import before you now run your code. Sorry, I didn't add to random. np.random. It's correct now. Okay, let's try 2 by 2. I don't take some position argument. np.random.random 2. Okay, so you can see it's generating 2 random numbers. I can say please generate for me 100 random numbers. Now someone should be asking me why do I need this? As it has just generated random numbers. So I can also say .rand.int. I think there's also .rand.int. So .rand.rand. There's a rand. So you just generate. Why you'll be asking why do I need all these functions? You need it because, for example, there are times you need to do mathematical functions, but most times anyway, for what we're doing most times for data science, you wouldn't really need this function, right? But it's just very good to know it because you don't know what level you are going to get to in your machine learning career. So okay, you have successfully installed pandas. Wow. So instantly now you can work with pandas. But before we proceed, let me quickly run us through this again and I'll take questions. So now dive deeper. Now, these are things you can do. So np.int, data types, the Boolean, the Unicode, right? These are things, this asking for help, np.info. So you can see we need help as well. Instead of using help dot, so you can also use np.info.ndre.dtype. These are some arithmetic operations, a minus b, np.subtract, np.add. Add. So you want to add things to. So we're supposed to use add in that other one. So np.exponential. So np.square root. So this is where you see all these sign. All right. You have a is 60 degree, have you? A is 60. So you can say print what? np dot sign A. So what is sign 60, Seth? Do you still remember our math? Sign 60 is 0.866.
That's 0.866.
Yeah, but okay, this one is calculating based on, I think, is it rand now? You know, we have degree and yeah, I think I'm right.
Radiant.
Thank you, sir. So you can do cost. So you can find the square roots. So these are some of the things you have under. So I'm going. This is the cheat sheet. This is. Let me just be frank with you. This is what I use when I started out. You know, I cannot. I'll just come here and check it, launch it, check it, launch it. So you can see what you can use to aggregate np.sum. The reason is because I think this person called out. So in this place now, why do you think this is saying a.sum? Because most likely before this person came here, he has called. So I can use, I told you can use, instead of import numpy as np, you can say as a, as b, as anything you want. So most likely for this sum function now, the coder has said, okay, import numpy as a. So a.sum, a.mean, b.com, std. You can also copy arrays, a.copy. So if, for example, I have this f equals to np dot zeros 2/3. So I forgot 2/3. Now I can say g equals to f dot copy. Yes, sir. np f. If I call g now, you see that g will still give me 0 because I've copied the values of f into g. Right? You can sort, a.sort. You can use numpy as well to slice. So you can slice through. So I want us, why I'm really overing through all this is you can do a lot of all these things as well with pandas, which is the major tool. So you can transpose. So after that, you see another one, which is pandas. So this is the cheat sheet for pandas, from data frame to what you can do and all that. So I will share it with you just to make it handy. You'll be joining the session again very soon. This class will end in the short one. Python for day 4, you can see this is for matplotlib and this is for scikit-learn.